Hello, everyone. Welcome back to my correlation plot video tutorials. Today, I'm going to show you how to plot the p-values on your plot. First, let's load the package Corrplot. Then we can use the multicast dataset again to create a correlation matrix. So to get the p-value, we can use the call mtest function. This function performs significance test to produce p-values, and at the same time, it also produces confidence intervals for each pair of the data input. So we can set the confidence level as 0.95, so the significance will be 0.05. So let's get the p-value and the confidence interval as test RES. We can run to get the p-value and the confidence interval. So you can see we produce the dataset contains 3 lists. We can click the dataset, have a look at the data in each list. You can see the first one is the P, the second one is no CI, third one is up CI. So P is the p-values matrix. No CI is the no bound of confidence interval matrix. And up CI is the upper bound of confidence interval matrix. So we have the p-values now. We can plot the p-values under the plot. So we use the pmat argument to show the p-values on the plot. In default settings, we don't show the p-value. Then the pmat default setting is null. We can run with the pmat default setting as null. You can see we produced the upper part of the plot. And here is the correlation plot. We don't show p-values on this plot. If we get the p-values for the pmat, we knew in the list p is for the p-values, so we can get the p-value for the pmat. We can run this code again. Let's run. You can see now we add a cross on those grids. If neither cross, that means the p-value is not significant. For example, for this cross, it's between the data HP and AM. So for the rest demonstration, we are going to just use the upper part of the plot. So next, I can introduce the in-sig argument. In-sig means not significant. So we can set 5 different variables for the in-sig argument. The first one is the PCH. So PCH is the default setting for the p-value plot. If we put the in-sig argument as pitch, then we will produce the same plot as this one. If we run, you can see there is no change on the plot. So the plot is exactly the same as this code. If you don't want to use the cross on your plot, you can leave the data blank. Then we can set the in-sig argument as blank. If we run, you can see now we don't show the data on the correlation plot for the p-values that are not significant. You can also show the p-value on the plot. If we set the in-sig argument as p-value, we will show the p-value that are not significant. You can see now we added the p-values on those grid. They are bigger than 0.05 because the default setting for significance is 0.05. You can also do the other way. Just label the data has significant p-values. We can set the in-sig argument is label significant. If we run, you can see now we label the grade with the asterisk to show the significant p-values. Next, I'm going to show you how to use the significant level argument. So the default setting for the significant level is 0.05. If we set the in-sig argument as p-value, if we run, you can see we only show the p-value that are bigger than 0.05. Then we can set the significant level as 0.05. We will produce a plot exactly the same as this one to show the p-values that are bigger than 0.05. Let's run. You can see we don't have any changes for the plot because the default setting for the significant level is 0.05. If you consider 0.01 as significant, then you can set the significant level as 0.01. Let's run. You can see now we label all the grades that has the p-value above 0.01. You can also use the significant level argument to show all the p-values. So if we want to see all the p-values, because the p-value in the diagonal boxes are 0, so we can set a value that below 0, for example 0.001. Then we can show all the p-values on the plot. Let's run. You can see now we show all the p-values on the plot. That's the way how you can use the significant level settings to show all the p-values on the plot. You probably see in lots of publications, we consider the 0.05 as significant, but in most of the publications, we also show the significance level for the 0.01 and 0.001. Normally, we can use 1 asterisk symbol for the significance level at 0.05, then 2 asterisks for significance level below 0.01 and for significance level below 0.001. We can label it with 3 asterisks. So we can set the significant levels as 0.001, 0.01, and 0.05. Then we can label the significance on each grade. Let's run this code. You can see now the grades have 3 asterisks, means they have the significance level below 0.001. For the significance level between 0.01 and 0.05, we label it as 1 asterisk. For significance level bigger than 0.05, we don't have an asterisk in the grade. So this plot is my favorite plot to show p-values. So as I showed you, when we get the p-value, we also get the confidence intervals for the upper bound and the lower bound. So in correlation plot, we can use lower CI and upper CI to show the matrix data for the lower confidence interval and the upper confidence interval matrix. So in default setting, lower CI and upper CI will be null. So now we can get the matrix data for the lower CI and also the matrix data for upper CI. So if we get the matrix data for both lower CI and upper CI, then we can use the plot CI argument to set our favorite plot to plot the confidence intervals. So my favorite one is the rectangle. There are other variables you can set. For example, you can set to circle, or square. Here I just demonstrated using the rectangle argument for the plot CI argument. For me, this one is the best one to plot the confidence intervals on the correlation plot. So let's run. You can see we generated the full plot for the lower and the upper confidence intervals. You can see the color in each box represents the correlation value. The upper side of the rectangle indicates the upper bound of confidence interval, and the lower side of the rectangle indicates the lower bound of confidence interval. Okay, that's the demonstration for today's video tutorial. I showed you how to get the p-value, lower confidence interval, and the upper confidence interval from your dataset, and also how to plot the p-value, low confidence interval, and upper confidence interval matrix data on the plot. So normally in our publication, the p-value is very important. So I hope this video can help your data analysis and to show the p-value on your plot.